Hey everyone, this is Derek, and in this video we're going to look at future value of ordinary annuities. So if we go back to that sheet of notes, which now I have to find. So far we've seen compound interest, so that was 6-1. So now we're 6-2 annuities, and these are going to be future value annuities because we're also going to have these things called payout annuities. The next one, they're going to be present value annuities. And so for these annuities that are the future value, the key thing there is we're going to be making lots of deposits. So when it was compound interest, we just made one lump sum deposit and then the money sat. But most of the time we don't really have $150,000 kicking around to just sit somewhere. And what we're really going to do is make payments on it. We're going to put money in month by month. And that's what an annuity does in terms of a future value annuity. It lets us pay into something and then save that way. Okay, so, and here you can see the formulas are getting a little bit more complicated. So rather than having the MT and the R over M in it and having fractions in my fraction, that's where I kind of like using the I and the N. Let's see, future value is still what it is. Everything is the same, except now we have added this lowercase p. Some books use R, some books use PMT for payment. I'm going to use a lowercase p, not to be confused with the uppercase P, which is principal or present value. Okay, for this first one, we deposit $100 each month into an account earning 4% interest compounded monthly. How much are we going to have in 25 years? So this is where we really want to start making that list. Otherwise, we will get really mixed up on what things are what. So how much are we going to have in 25 years? Sounds like a future value. So that's what we're trying to work out. Our payments are going to be $100. Interest rate was 4%. Compounded monthly, so that's our M is 12. And then T, 25 years. And so then that's going to make I is going to be the 0.04 over the number of compounding periods, which is 12. And then the N was the M times T again, and that makes 300. So now we're going to take all this and then jump it in this formula. So our future value will be the payments, $100, and then 1 plus this, to the N, and that was 300, minus 1, and then all over I, and that is 0.04 over 12. Okay, so once we get all that typed in successfully, you should get future value is $51,412.95. And to type this in the calculator, what I would probably do is I would type this chunk, raise it to the 300, enter, and then go -1, enter, divide by that number, enter, times 100, enter, and not try to get all the parentheses in the right spot. So for part B, how much total money would you have put into the account? Well, we made $100 payments every month for 25 years, and so that comes out to $30,000. And then how much was the total interest we earned? So again, that's the difference between our future value and what we put in our principal. So that would be the $21,412.95. Okay, for this one, a man wants to set up a 529 college savings account for his granddaughter. How much would he need to deposit each year into the account in order to have $40,000 saved up for when she goes to college in 15 years, assuming the account returns 7%? So we are trying to figure out, this is how much money he wants in the future, and it's how much would he need to deposit each year, so that's payments. So that's what we're trying to find. Future value, he would like to have $40,000. 15 years, there's our time, there's our rate, and then this was each year, so then it's annual. So that's nice. That makes M1, which means the time and the rate. We don't have to do the division because it's by 1 or multiplication. So future value, that's what we get out. And then payments are what we're putting in. And this will be 1.07 raised to the 15 and then minus 1 over the rate. And then I just made this a number and then 40,000 divided by that number. And that got me payments of $1,591.78 each year. Okay, for this one, a business sets up sinking funds that they'll have $52,000 to pay for a replacement piece of equipment in 8 years when the current equipment will be sold for scrap. If they make deposits at the end of each month for 8 years and the investment pays 7.2% compounded monthly, what size payments do we need to make? We're going to 2 decimals because it's money. Okay, so our future value, they want to have 52 grand. Payments is what we're trying to work out. M is each month, so that's 12. T would be the 8 years. And then rate 7.2. So that's going to make our N, which is our total number of compounding periods, 12 times 8, which is 96. And then our rate will be, interest per compounding period will be the 0.072 divided by 12, and that comes out to 0.006. And then back to that same formula, so we get 52,000 out, and we're looking for the payments we would have to make, and then 1.006 to the 96 minus 1 over the interest. And again, we just turn this into a number divided into 52,000, and it looks like they need to put in $402.14 each month.